Prep 7, Simple Linear Regression. In this video, you will learn the purpose of a regression analysis, as well as the difference between simple and multiple regression. You'll also learn how to conduct a simple linear regression in Excel and how to interpret the output from that analysis. You'll also learn how to create and use the regression equation that results from that analysis. Regression is a commonly used statistical analysis in business. That's because regression allows us to predict one variable based on the knowledge of another variable. Thus, regression is a great tool to use if you want to be able to predict or estimate something. In regression, the y variable is the predicted variable. This is the variable that you want to be able to predict. The x variable is called the predictor variable. This is the variable that's used to estimate or predict the y variable. It's very important that you correctly identify your x and y variables when you conduct the analysis in Excel. If you mix them up, then the results from the analysis will be incorrect. Here is an example. In this example, a researcher wants to determine if she can estimate a restaurant's weekly revenue based on the number of website hits they get each week. See if you can identify the predictor and the predicted variable. The predictor variable, variable x, would be weekly website hits, and the predicted variable, variable y, would be the weekly revenue. The predictor variable, website hits, is being used to estimate the predicted variable, which is weekly revenue. This is an example of simple regression. Simple regression is when you use only one predictor variable to predict y. Multiple regression is when you use more than one predictor variable to predict y. For example, if the analyst wanted to use weekly website hits, square footage of the restaurant, and the population size, then the analyst would need to employ a multiple regression analysis. This module will cover simple linear regression. The next module, you will learn how to conduct multiple regression. In order to conduct a simple linear regression, there's a couple of conditions that need to be met. First of all, there should only be one predictor and one predicted variable. In addition, the relationship between x and y needs to be linear, and both variables need to be quantitative. This analysis is only appropriate if both of the variables are quantitative. A regression analysis will let us know if x actually does predict y in our data set. If it does, then the analysis will create an equation that we can use to predict future cases of y. First, we want to know if x actually predicts y. We are going to use what is called the p-value approach to answer that question. The output from Excel will include a number that is called a p-value. P-value stands for probability value. This number will tell us the likelihood or the probability of getting our data if x does not predict y. If you remember from our example, the researcher had data regarding website hits and revenue from 30 restaurants. The p-value indicates the probability that the researcher would get the data if website hits have nothing to do with weekly revenue. Obviously, we want our p-value to be small. We think website hits actually predicts weekly revenue. So we want a small p-value because that means it would be unlikely that x doesn't predict y. If it's unlikely that x does not predict y, then there's evidence that x does predict y. So what constitutes a small p-value? Typically, a cutoff of 0.05 is used. That means if your p-value is less than or equal to 0.05, we will conclude that we can predict y. If the p-value is larger than 0.05, then we'll conclude that x does not predict y. This is what output looks like in Excel after you conduct a regression analysis. I conducted a regression analysis for our example of using website hits to predict weekly revenue. When you do the p-value approach for a regression analysis, there's actually two tests. There's two parts to the p-value approach. The first part is known as the global test. If your p-value is larger than 0.05, that means the x variables do not significantly predict y, and you do not move on to the second part. Your question is answered, x does not predict y. If your p-value is less than or equal to 0.05, that indicates that at least one of the x variables significantly predicts y. Here's where you can find the p-value. You can see that our p-value is 0.0288. That's less than 0.05, so that means at least one of the x variables significantly predict y. So now what we can do is we can move on to the second test, which is the test for individual coefficients. This allows us to see exactly which x variables predict y and which, if any, do not. Well, we're doing simple regression. We only have one X variable, so that means the global and individual tests will always be the same. And you can see that the p-value, which is circled in red, is the same. It's 0.0288. So when you're conducting simple regression, the global and the individual tests will be in agreement. However, when we move on to multiple regression in the next module, the global and the individual tests will become more important. But for now, just know that the individual and the global tests will always, the p-value will always be the same, and it will indicate if X does predict Y or if it doesn't predict Y. Again, if it's less than or equal to 0.05, that means X does predict Y. So in our example, website hits can be used to significantly predict Y, or weekly revenue. So now we know that website hits can be used to predict or estimate weekly revenue. So now we want to be able to do that. We want to be able to estimate weekly revenue. So what we're going to do is we're going to determine what the regression equation is. This is what a generic regression equation looks like. Y hat represents the predicted value of Y. B sub 0 is the y-intercept. B1 is the slope for the predictor variable, and X is our predictor variable. First, I'll show you how to determine the equation from the output. Then I'll discuss what the y-intercept and the slope mean. Here's where the y-intercept is. So the value for the y-intercept is 9,678. Here's the predictor variable. Again, our predictor variable is website hits, and the slope is 2.24. So now what we can do is we can create the regression equation. Y hat, again, is the predicted value of Y. Our Y variable is weekly revenue, so Y hat would be predicted weekly revenue. Again, the regression equation is the y-intercept, which is $9,678, plus the slope, which is $2.24, times the X variable, which is the weekly website hits. So this is our regression equation. And now what we can do is we can use this regression equation to predict future weekly revenue. So all we have to do is plug in the weekly website hits, and then we'll get an estimate of what the weekly revenue is. So exactly what is the slope and y-intercept telling us? The y-intercept tells us the predicted value of y when X is 0. In our example, that would mean that we predict that a restaurant will have a weekly revenue of $9,678 if they have 0 weekly website hits. Again, website hits is X, so if X is 0, they don't have any website hits, that means we would predict that their revenue would be $9,678. The slope, on the other hand, tells us the predicted change in Y if X increases by 1 unit. If the slope is positive, that means there's a positive relationship. So if X increases by 1 unit, that means Y is predicted to increase. If the slope is negative, that means there's a negative relationship between X and Y. So if X increases by 1 unit, that means Y is going to decrease. In our example, our slope is $2.24. That means for every increase in 1 unit of X, so every increase in 1 website hit, results in a predicted increase of $2.24 in weekly revenue. The regression equation is an equation for what's known as the regression line. You can insert a regression line on your scatter plot in Excel. Again, this line is the equation. We can also view this line as the predicted values of Y. So you can go to your chart, you can see if website hits is around 1,500, we can go to our line, and this is the predicted value of Y. You can see that weekly estimated or predicted weekly revenue is roughly 13,000. Obviously, if you really want a more accurate prediction of weekly revenue, you would plug in website hits into the equation. However, the scatter plot, the regression line on the scatter plot, is going to give you a rough estimate of what your predicted Y would be.